Hi, good morning everybody. My name is Alex Toy. This is Joseph Elbaz, Jason Smith, Zane Hovey, and Stephen Foster. For our project, we made mobile mesh network extenders, and in layman's terms, we basically just stuck wireless extenders on drones. And so, basically, our vision with this.
No color.
Sorry.
So, our vision for this was to connect a whole community from one gateway, such as a public library. It has applications in like disaster relief areas or places with low internet connectivity, like a rural area. So it can kind of be thought of as like two parts, the network and the drones. And so the network runs on OLSR, which is a IP routing protocol specifically for mobile ad hoc networks. And basically each drone has a Raspberry Pi, or in our case, a custom PCB to increase efficiency. Each drone acts as an access point that users connect to, and then each drone communicates with each other and routes it back to the gateway. And to control the drones, we're basically sending packets from the drone autopilot to the PCB, which then forwards it through the network to a server that's running a ground control station. And the ground control station basically just will aggregate all the information, such as latitude, longitude, altitude, etc. And then we'll also send commands through network to the PCB, which forwards it to the autopilot, which will arrange how the drones are in the mesh network. Basically it. Any questions?
So I'm sorry, I'm trying to understand the problem statement itself. So you're trying to use the drones as an access point?
So the drone has a Raspberry Pi, or in our case a PCB, that we created that is the access point. So the drones are basically just to move the node, or like the access point.
We daisy chain them to extend your network connectivity. So you have like connectivity here, and then you can use the drone to bounce it to here, to here, to here.
Okay, so how do you keep the signal strings from getting lost from the original one?
That's the OLSR network. It's an optimized link state, so that each one is automatically repositioned so that they continually daisy chain that signal. So if it starts to weaken, then they all move in conjunction to wherever there's more need or to have continuity.
So you're suggesting this during a disaster recovery. What is your backbone connection? How do you connect to the network?
Yeah, you have one server access point. From there, all of the
but you're in a disaster, so
right,
you have access to that.
Yeah, you do need a base source. So that base source is in a, and you could have some sort of network connection. At that point, it then extends it beyond. So it's essentially creating like a Wi-Fi network that's got miles of range rather than just feet.
Like for example, UT Dallas, right?
Right.
Say we have we don't want to foresee that, but if there is a disaster, okay, you already have a mesh network here. CommentNet is already there, and it goes down, and you want to connect, but you still need CommentNet to connect to the internet. That connectivity, what's the value proposition here?
Right. What we're assuming, there's assumption there that we do have at a distance, we have one base network. So that's the assumption, and that's sort of outside of our scope. But from that one position, our focus is on the areas that would not normally be able to be reached.
So did you think about using one of those drones to communicate to a remote site?
That's essentially what it's doing. So we have, it could be one drone in between, or it could be 10 or up to 25.
So what's the time that, so typically drones have a relatively limited time of flight?
So our flight time with one battery is roughly 9 minutes, depending on how hard you fly it and the propellers used. For two batteries, which we can't handle the weight, it'd go up to about 16 minutes.
Does that solve your issue of needing?
We're not
Drone
actually
possession.
hovering the drones when we get to a point where we want the internet to be. Instead, we're actually landing it
Okay.
there.
And then you have uptime, once it's landed, our PCB and battery lasts a lot long, that
Okay.
could last into the hours or.
That's fine, we're landing once we get there.
Right.
So what's your range, maximum you can extend?
It's limited by the network, which is
Right, 25, up to 25 access points, so 25 by 500, so it gets a fair
Okay.
distance.
How did you come up with that 25 number?
That's actually, this is a continuation of another project. The 25 is part of the OSR network, which was done before us. So we're taking existing code and moving it onto our system.
And we tested part of it when we ran the network and connected to it at increments. We obviously didn't get all 25 running back to back, but the distance between the ones we did test was around that.
What was the latency?
Again, that would, I would have to say that would probably fall under the previous part, because the OSR network part is not the part that we actually designed. But, so I,
So you guys did not test the latency, right? And that's
no,
big.
no, not latency.
That's where the usability of this entire mesh network is. If it's beyond, if I can't browse the network, then there is no use of it. Anyways, good job.
any other questions?
Thank you, Bruce.